to the second live hybrid event of Circuits 2020. Thank you all for following us. It's been a great week. It's going to be a bit of a hard tour today to end this event, but obviously I'd like to remind you that Circuits will be going on, and later on I will be giving you details of further events of Circuits 2020. This year Circuits came in a particular situation that we all know about, but yet we soldiered on, and we can say it was really worth doing. I have to say that our videos have been viewed by around 9,000 people already, and for us as a small voluntary organization organizing the specialized event in Malta, this is a great honor to have so many people interesting themselves in our activities and interesting themselves in general on Circuits, this Circuits event. This year Circuits was special for many reasons. Besides the fact that it was still held and we still soldiered on during this pandemic, Circuits is the first time that in 3 consecutive years that we will be supported by the Arts Council Malta, whom I really thank for the support. And this is the 5th edition of Circuits, which from day one was always supported by Spazio Creativ. And again, I would like to thank Spazio Creativ for their support. We are here today live from the theater of Spazio Creativ. Originally, we had intended for both hybrid events to be on the roof, but we were unfortunately not graced with the winds, the typical winds of October. So we had to keep on soldiering from inside this magnificent theater. I would also like to thank finally the German Maltese Circle through the Goethe Institute, who have supported us by providing us with sponsorship for Tom Ammerman and for the spatial sound experience. Which brings me to today's event. This year was special also for another reason, because this year we managed to have 2 great projects. One project we covered extensively. It's called Away from the Comfort Zone. So far we've premiered 2 of 5 performances. Yesterday we had the premiere of Wildfire, and next week we hope to have the premiere of Le Tombeau de Tristano, a collaboration between Luc Houtkamp and Mari, who operates the Teramashka. And the second project, which this year we're really proud of, is a project which finally we are, I think, the first ever organization in Malta to commission a sound device, a synth device that can be easily built by the public. And we've decided to, obviously being patriots we are, to call it in Maltese Storbju, which means noise. And obviously these 2 guys here, whom I will introduce shortly, christened it as the Noise Monger. And I will obviously talk by mentioning Mike Desira and Frank Cachia, the former, a person who we were surprised, myself and Owen J, that there was this exhibition and someone told us there's someone who's building modulars in Malta. We thought it was some sort of joke, but then when we visited the trains exhibition in Nashar, we were taken away, and even Mike himself never knew that there was a following of modulars in Malta. And this was about 3 or 4 years ago, and this was the start of a long collaboration and friendship with Mike. And naturally, we had one day to say, Mike, let's design this Noise Monger, this device, which obviously we didn't know. And our natural other person that we would then resort to is our always technical and electronics, I would say, go-to person, Frank Cachia, whom I've obviously known and collaborated musically with as part of Duo Blank and other projects. And obviously, this project was started off, and now we are so proud to say that today we shall be demonstrating the first working prototype of this device, which in the coming weeks, and here I obviously invite everyone to keep themselves updated, because we will be then launching it for sale for the public, and eventually in December we will be also doing a proper workshop to obviously provide instructions how one can assemble it. But enough from me, because this is all precious time lost. I will leave up to Mike and Frank for them to do the actual presentation of Storbju. Thank you very much.
Thanks, Edwin. Okay. Okay. Thank you, everyone. I would like to thank Edwin and the EMM for the opportunity they gave me to be able to provide something to make noise, basically. Those who know me know that I really like noise. Anyway, some time ago, I got this phone call from Edwin, and he said, Mike, we would like you to come up with something which is relatively simple so that the public can understand, which is easy to construct with minimum skills, and to provide a sort of gateway to the general public into the world of sound synthesis. And fortunately, there are a couple of components in electronics which I am sure their designers never imagined that they're going to be used or abused in the way that I did. And I managed to come up with this little box of tricks which fits neatly into that brief. The prototype is, as Frank is showing us, it looks like some tomato and parmesan short of spaghetti plate, but what can I say? It's the prototype. So it was a build as I go along. Basically, I took the tenet of sound synthesis in that you have resources which are freely and independently available from each other, which one can connect them together so that they can produce a sound. In order to do this, one has to define what generates sounds and what can be used to affect the sounds. These are all connected together, and finally they are presented into an amplifier. To do that, I came up with this design, which is basically 6 oscillators. Typically, an oscillator is an electronic device which produces a frequency. It can go up into radio frequencies, but here in synthesis we are interested in the audio band, so I have configured it to produce audio range signals. The chip is able to generate 6 channels of frequencies independently of each other, and I have taken advantage of this in configuring it to provide 6 audio oscillators, but 3 of them can go down below the audio frequency range so that they can be used as what is called as modulators to the main oscillators. For me, and probably the only way to look at this is like an artist, a painter artist palette of colors. Instead of colors, we have resources, and instead of the paintbrush, we have what we call patch cords, which we connect so that we can wire it in particular ways to make it the effect we want. Basically, it worked. There were some improvements in it, in that once you got the basic tone structure going, you can shift it up and down the frequency range. And as a nod towards the theremin, which is an instrument, as maybe some of you know, which can be controlled without touching it, I came up with an idea to make this in a sort of a theremin way, but light sensitive rather than radio waves. As Frankie will show you here, patching is by connecting from one side to the other. These are the outputs and the inputs. This will be shown at a later stage with the thing. And from there, I presented this prototype over to Edwin so that he come up with a feasible PCB. I will now turn over to Frankie so that he can explain to you the saga of coming out with the final product. Over to you, Frankie.
Thanks, Mike, and thanks, Edwin, for the introduction. So To continue from where Mike left, then this project came to me, so that, because obviously we had to present it in a manner which is sellable, or in a way to present it to the public. So obviously the circuit was designed by Mike with all the things in it, which is fabulous. But then we have to create what we call the PCB, the printed circuit board, to mount it onto. Because Mike built the thing on a Vero board, which is a board which a lot of designers use so that they can create and test things on it. Then after that, the project goes to the other stage of the PCB. Then I had to, because it had been a while since I had designed a PCB, and the way I used to do it was in the old way, a way which is purely manual. I had to go, this project was meant to be sent to a production house so that they can produce the final PCB. So from that, I had to research the way I have to do it to send the project to them so that they can produce it. So anyways, to cut it shortly, I found out that I need to use a certain software so that I can create. Firstly, I had to take the circuit diagram, the schematics from Mike, and input them into this software, particular software, so that I can design the circuit which shall be functioning. So from there, then we got to place the components on a PCB. So I did the placing of the components in a way. So this is what I'm showing you here is the first prototype we did. And over here you can see the placing of the components. After doing the placing of the components, you have to link the placing to the circuitry, so as the software will generate the red lines, the so-called red lines, which are the lines which are connecting the components to each other. I hope I'm not getting too technical into this. No. Anyway, but finally we ended up with this project, with this product, which as you can see, maybe if I tilt it a bit, maybe the lines can be seen underneath the black paint. The PCB is also two-sided, so we can make it smaller, because otherwise, due to the amount of components there are and the links in between them, to generate it on one side, it has to be bigger. So to make it smaller, I had to use both sides of the PCB. So you can see that on both sides there are tracks going from one component to the other. From then onwards, we found a production house, and I send them the software, the file where I created the thing, and we started with the first prototype. We got this board. When we received it, I also ordered the parts for it. I ordered five boards, where me, Edwin, and Mike, we built one each. And from there we started the testing. We found out that there were some things which were not right, and that I needed to correct. And also the design was, so this is the PCB which we built, the first one, which, as you can see, have the single inline patch connectors on the side, each next to each potentiometer, and you have the potentiometers on both sides of the PCB, while the main controller is on the side.
Actually, it's a saner and more logical representation of the
original,
which we have provided.
But then when we discussed it all together, we found out that it would be better off if we change the whole setup of how it is and put the controllers all on one side and organize the patch connectors so that they will be also defined with good wording around them, and which are more easy for the users so that they can create something which is more in a more logical manner. So then we came up with the second prototype.
The final result.
Which is almost the final result. And we came up with this, where we have the controllers of each oscillator on one side. We have the first three, which Mike explained beforehand, which are the audio frequency, the higher part of the audio range potentiometers, and we have the three modulators. The lower can also reach audio frequency, but can go down to frequency sub audio. So we can control, like we know it mostly in the synth thing, LFO, low frequency oscillators. Then on the upper side of the board, patch connectors, and they are in a manner and marked so that everyone can understand them clearly. So we have the modulation inputs, because each oscillator can be modulated with another one. So each oscillator has two modulation inputs. Then we have the outputs of each oscillator. We have two passive multiples where you can patch like the modulations or also the audio signal to send them back to the mixer. So the last one is the mixer. And on the mixer we have a two-channel mixer, so that is left and right. And basically that's it. And now we can go on to present how the simple functionality, and we can elaborate a bit more too. Mike.
I think it's one have to note here that as like in an artist's palette, you have the separate colors. When you look at it, you have the separate colors. To get the color you want, the mix, you have to mix them up in particular ways for that to happen. In this case, Frankie will now switch the unit on, and we have to switch this on too. Okay, and obviously nothing happens because nothing is being mixed into. As Frankie will show, we will first patch one audio oscillator into the output,
directly to the mixer output. And as you can see,
we can see and that is one. He will now patch into another audio oscillator and patch it into the other channel.
So I have kept one in the low frequency range, the other one put a little bit on a higher frequency so they can be distinguished from each other. Now from that I can take another output of one of the low frequency modulators. I can patch it to the patch bay, to the passive multiple, and from that I can control the other two oscillators. So as you can see, I'm varying the modulation frequency here. So the sixth oscillator is the modulator, while the first and the second are the main oscillators. Apart from that, Mike also mentioned the overall controls which we have on the side. So we have this controller over here, which is basically tuning the whole circuitry in total. Then you can switch from the potentiometer over here to what Mike just mentioned, which is an optical sensor over here, and we can control the circuit by the light.
Work well if it had just a single source of light, thank you. But at the
Yeah,
moment
but
we have
light coming from everywhere.
Yes, from everywhere. So, but basically that's just a demonstration, demonstration of what's going on.
So, what we can say about this project, this is a versatile, because it's not a tuned synth as we know them, which is tuned to a particular frequency range or whatever, or to particular notes or particular scales. But this is like generating noise not randomly at all, after all, but not in a perfect pitch way. So
I would say that the right description for it would be a drone machine, actually, rather than a musical instrument, because there is absolutely nothing musical about it, as you have heard. And in fact, I would encourage the kids to get one of those and build it to create some headaches in the household and in the neighborhood. Eh?
Yeah, but it's very easy to build.
Yes.
As you can see over here, the components we have used the conventional components, which can be easily picked by the hand, no SMDs used over here, so no lenses in a way.
It is also very easy and logical the way it is set up. Very easy to follow the instructions, which will eventually publish
will
online.
Be put online, and further on we will also demonstrate the building of one synth.
As we have said, it is meant to be very easy for the general public to assemble and use.
So, okay, I think that one, hello, okay. So, I'm gonna ask a pertinent question now to Mike. we always have all these synthesizers with all these oscillators in, but an oscillator can be designed using something really, really simple to set up. Over here we have I would say a very interesting implementation of a 6 oscillator machine, which we will be launching obviously and which will be available for the public. But yesterday I challenged Mike a bit because I'm used to going to these do-it-yourself building labs, maybe not in Malta, but more in places like Berlin, for example. And we generally are challenged to build simple oscillators using breadboards. Obviously, on the fly, it wouldn't be something streamed, so accidents might happen, and obviously not the thousands of people that are viewing us would be viewing them. So, Mike, I challenged you yesterday, and immediately you told me, I'm not going to do it on breadboard, I'm going to do it on the Vero board to give an example how such a device, obviously to have it as reliable as possible, but at the same time to show how a simple device, how much did it take you, Mike? Obviously you're very experienced, but it took you, I believe, maybe 3 to 4 hours, and your wife was possibly mentioning me in her prayers.
Well, actually, you phoned me at around 2 o'clock in the afternoon, and I had to produce this, whatever, like in less than a couple of hours. It took me all of maybe 2-3 hours to do that, but the assembly took some time for it to happen. Suffice it to say that at 2 o'clock, the wife came over and said, stop making strange noises, actually. And I said, it's all for Edwin, so my wife needs to have a talk with Edwin now. So.
Exactly. So this is well overdue, I think, now. Yes, so maybe you can show us a bit this very interesting oscillator.
Basically, for those who are in the know, there are 2 integrated circuits, which are the ubiquitous NE555, which is a simple oscillator board, industry standard. Everybody knows about it. I have configured it into a single oscillator, and the other chip would vary its frequency regularly as a sort of vibrato for those who are into music. The controls are the 2 orange knobs over to my side. These 2, those are vibrato frequency and vibrato intensity. So if we shut them down, the other one is a volume control, and perhaps the musical people would recognize this as a somewhat original rendition of a chromatic keyboard. I managed to squeeze a little bit more than an octave, a chromatic octave of 12 semitones each on the here. As you can see, with Frankie is the musician from us here, and he will demonstrate to you. The horror movie from which we had the soundtrack will be coming out next year. It has all the makings of a basic organ. The sound isn't that much, but we have to keep in mind that for the amount of components in it, it's really quite effective.
And obviously, the simple question that arises from people is, how much would such a simple device like that, a square wave oscillator with a keyboard, cost? I would believe it would cost peanuts.
In this case, the most expensive things are the switches, believe it or not.
Tactile switches, yeah.
Otherwise, it's only a couple of euros, especially if the components are sourced from the normal, from outside the island. But really, they are components which are readily available. There's really no problem in sourcing the components to get it running, actually.
Now, coming back to Storbju, well, thanks very much, first of all. An applause to Mr. Desira for this really, really interesting, very quickly, I would say, generally, in the past editions of Circuits, we once did the 10-minute challenge. I did the 2-hour challenge to Mike to build an oscillator. But now going back to Storbju, and going back to generally, some people would not be in the do-it-yourself, like building. And an important aspect, I'm just going to explain a bit about the process now. Storbju and devices similar generally are presented, we will have a web page that will be supporting this device. And generally, with such a project, the public would be acquiring the PCB board and acquiring alongside the PCB board a small bag with all the components. And an important manual that comes alongside, which I believe, Mike, I think you have next to you there. Do you have? I don't have it. It's okay. No worries. An important manual that will be available is the bill of operation. I think it's called
bill of materials.
Bill of materials, which will be something which will be available in our website, and whoever will be acquiring this device, they will have the opportunity to get to know a bit about how the components look like, because there are so many little parts, and this is something, Mike, that eventually in December we'll have the time, and even we'll have some basic videos also on the Storbju site to explain a bit what is a resistor, what different ratings of a resistor, the coloring on the different resistors to distinguish one alongside the other, and all these basic stuff. But in a nutshell, everything will be available. We will have the parts available. We will have this manual available. And obviously, following the course, we will be having a tutorial video available, because we will be filming the workshop, and eventually the tutorial video will be available. But obviously, we will be challenging some local producers in the coming days to jam along using Storbju. There will be, I would believe, there will be sound clips available, and there will be also some short videos available to explain how this Storbju works. Also, another thing that I wanted to mention is that currently I'm inviting everyone who's viewing this video, especially around, not live, but around the date we recorded it, to come and visit the exhibition we have at Spazio Creative. It's at Space B in Spazio Creative. And this exhibition we have boxes similar to this one, but they have something special inside. They have copies of the first prototypes of Storbju inside, and the people and the public can interact with these boxes and obviously trigger the various parameters that Storbju has. So I don't know whether I haven't seen any online questions as yet. Frank and Mike, I don't know whether you have any further questions and any further things to add.
We're good.
We just advise the general public, those who are interested, that they can approach Electronic Music Malta to get the PCB together with the pack of components as soon as it is available.
Yes, so obviously from our end, we will be soon also launching a new website. And with the launching of the website, we will be launching the news when Storbju will be available for the public to actually set it up.
With regards to the construction in general terms, as Frankie has shown you, it is a very simple PCB to follow. All one needs is very basic soldering skills, year one school soldering skills, and there really are no delicate, I mean, you can't play football with them, but that would break it up. But apart from that, you really have to try to make it not work. The only thing which is a little bit what has to be taken care of is this little bug here, which is an integrated circuit. However, we have gone through the provision, making it first through a socket, so you abuse the socket as much as you want, and when you have everything working okay, you can just plug the chip in and go. With regards to instructions, there will be this bill of materials, a BOM. Basically, you work with it so that you would know which component, which place. Even it is suggested that you stop during the construction, go have a cup of tea, go play with the cat, whatever, just relax and then go back again into it. And
excellent. It's very important to know that some people might be, obviously, I remember myself when I was jamming along the very cheap monosynths, and some people would sell them to me unknowingly that without any effects, without any chorus, without any reverb, they sounded really whatever, shite. But as soon as you connect any other device, so what we're hearing today is definitely a device that is untreated with any reverb, untreated with any delay,
exactly.
And untreated with any other sort of effect. But one important thing is that the main output of this device, and this is a point I received online, it is very simple to connect using a simple headphone connector, no? But an important thing to note is, please, for the people not to connect something like that. Eventually we will obviously be advising not to connect it directly via headphones, because it's quite noisy, it's quite loud. So ideally one connects it to a mixer and then applies effects to it. A very important thing to note, and this is something I wanted to ask you, Mike, because I was truly, how do I say, taken aback and happily when I connected this device with a CV sequencer. So I literally crafted a small cable. I replaced it from the power supply and put this CV out from a normal analog sequencer into it. And this created some interesting, obviously not pitching, not obviously tuned pitching. And maybe, Mike, can we talk a bit about this? Because one thing that really impresses me about this small device is that you don't have a fixed voltage that you can plug it. Obviously, you cannot exceed, I would believe, 9 volts. But any range of voltage fed into it from 1 volt onwards would make it pitch differently. And then, in fact, you can actually connect it to a CV sequencer. Maybe a bit about this, Mike or Frank.
Actually, when you contacted me and told me that you managed to make it react to CV, I was very surprised myself, because I didn't think about it in that way. In fact, my train of thought was that this would not respond because it was just a generation of the way it works to generate the sound. I didn't think that would respond. However, this clearly demonstrates the synergy when something is built up with an intention, and then you give it to other people who might have other different ideas, which we will have when we will present it to established artists on the local scene here, so that we can hear what they can come up with too. You also mentioned that you built up a cable yourself. That is also another demonstration of how simple and how easy it is to spin off your own brand of effects, by which you can create your own signature sound with such a very simple and basic machine.
In fact, the intention is obviously to encourage the public as much as possible to jam along with this device, leaving it as it is, or possibly even come up with creative casing using today 3D printing or other similar materials. I would believe it's worthwhile noting, I don't know whether it was mentioned, that the potentiometers can be mounted both in this fashion or also at 90 degrees, so similar to that fashion, so one can set it up in a particular fashion. Obviously, one has to take into consideration the modulation section of the modular, I would believe, connector section of it. But again, Mike, I really would like to say well done, a big well done to yourself and to Frank for this. I know Frank never tried that. This was a new journey for Frank. It was a bit of out of the comfort zone, even this project. A great synergy between Frank and Mike. Yes, as I said, so basically this will be out because people are already asking me about the price. We will be disclosing the price very soon as we will be launching Storbju for sale. Obviously, we will have all the supporting materials with it. And today also, because it's a very special day, we have thought about Mr. Mike Desira and something for you for your birthday. Happy birthday, Mike!
Happy birthday, Mike!
Thank you. No, that's a surprise. No, that's nice. All right, okay.
Okay.
Okay. Thank you. Thank you very much.
It's not a turntable.
Thank you. For those curious, I just turned 61 now. And to be honest, I always this is what I'm doing here is a dream which I had ever since I was a very young schoolboy, during the age of the dinosaurs at the other century when I was about 13, 14. So thanks to AMM, I am given the opportunity to...
I would believe, Mike, you started off watching a BBC documentary
yes,
about
yes.
some sort of 70s
yes,
Tomorrow's World, or maybe...
There used to be, not Tomorrow's World, actually it was an American production. I really would like to find it out. But it was, the Moog synthesizer have just came out. I was born before the Moog synthesizer, so that's some credit to me. My mother and father anyway. And they really got me hooked. In fact, I would say that my interest in electronics stemmed from that moment when I heard the Moog synthesizer, which I managed to make some leeway in life with that. But I have been waiting for the opportunity to build something. The people who know me know that I have a large format modular. People online know me also. And I managed to make my dream come true, finally. Thank you, guys. Thank you very much.
Thank you very much. Well done, Mike. Thank you.
So this brings to an end this first slot of our final hybrid event of Circus 2020. We will be going offline now, hoping to come back online at about 1:30 with hearts beating in time live set. Thank you very much. Thank you, Frank, and thank you, Mike, for the presentation of Storbju Noise Monger.
Thanks to AMM.
Thank you.